Hey everyone, it is Mr. Vargas here. Just wanted to help out Math 3 really quickly with Operations on Functions Homework 5.1. We'll go over a few of the problems from your homework assignment. That way you can have that done and ready for class. Let's start out with the page titled Arithmetic on Functions, and in particular I want to highlight exercise 4. So, for these first 4 exercises in your homework, you're given 2 functions, and then you need to perform different arithmetic operations with those functions. In particular, you got to do addition, subtraction, multiplication, and division. So I've written those 2 functions here. F of x equals 2x minus 1, and g of x equals 3x squared plus 11x minus 4. Let's get started by first doing the addition. So I'm going to take 2x minus 1 plus 3x squared plus 11x minus 4. Alright, all we need to do here is combine like terms. So that would go with that, and that would go with that. My constants, go with my constants. So this would come out to 3x squared. Since I didn't have anybody to join with 3x squared, it stays by himself, plus 13x minus 5. Okay, let's go to the next one. F minus g of x. So this would be 2x minus 1 minus 3x squared plus 11x minus 4. Okay. Whenever you have the minus on the outside of parentheses, you need to use the distributive property and basically add the negative all the way through. Okay, now we can combine like terms here. Alright, so now I'm going to have negative 3x squared out front. And this time I end up with a negative 9x. And that would be plus 3. Awesome. Let's go down to the multiplication. 2x minus 1 times 3x squared plus 11x plus 4. Okay, you got to FOIL this thing out or use the distributive property. So really quickly, if I take 2x, multiply it by 3x squared, that's going to result in 6x cubed. Going to need some room here. Okay, and then I take 2x, multiply it by 11x, and that would get you a 22x squared. Alright, 2x times 4, get you a positive 8x. Alright, and then we got to do negative 1 times everything, so negative 1 times 3x squared is just minus 3x squared. Okay, negative 1 times 11x gets you negative 11x, and then negative 1 times 4 finishes it off with a negative 4. Combining like terms here, this would just simplify to 6x cubed plus 19x squared, get rid of those, minus 3x minus 4. Awesome. Okay, last problem here is the division. So we've got the function f, 2x minus 1 over, oops, let me do that in purple. You've got 2x minus 1 over 3x squared plus 11x plus 4. Alright, we can't really simplify this per se, but we can find out where our domain is no longer any good. And the way that we do that is we can factor that bottom into 3x minus 1 times x plus 4. And then basically whatever will turn this factor into 0 and this factor into 0 will cause this to have an error, if you want to think of it that way. We can't ever have 0 in the denominator of a fraction. So here x would not be able to equal -4, because if I replaced -4 in for this x, that would make this a 0. 0 times anything would be 0, making that whole bottom 0, so that's not good. And then x can also not equal, well, if I think about setting this equal to 0, I would add 1 to the other side and then divide by 3, so x can also not equal 1/3. Those are no-nos. Okay, let's go ahead and jump to the next page, composition of functions, exercise 2. Alright, so when we're talking about function composition, remember we want to think about what happens when you place one function inside of another function. So this time we'll start out with f composed of g, and we're going to run through all of the options of what happens when we plug g for its different points into f. So let's start it out like this. Let's do f of g, and we'll start with the first point of g at its x value of 3. Okay. So what happens when I plug 3 into g? Well, 3 outputs 7, so now this becomes f of 7. And then f of 7, what happens when I plug 7 into my function? If I go back into my input, or my points, my coordinates for f, there is no 7, right? I don't have any x values for 7. So here we would say that this does not exist. DNE does not exist for that particular point. Okay, let's move on, try the next one. So what happens when I plug f of g of -2? Okay, well, that would get me f, and g of -2 evaluates to 6. And then we can go back into our set for f. Do I have any 6s for my inputs? No, I don't. So once again, this is another DNE. Does not exist. Alright, well, maybe we'll have some better luck this time. What happens when I plug f of g of my next x value for g is 4, and g of 4 just becomes f evaluated at -2. And if I go back into f, I don't have any -2's in my x position, so once again we get another DNE. And last one, f of g of, this time we're going to replace it with 8. Okay, and 8 just outputs 10, so this is f of 10, and we'll see if anything matches up for our x values. Nope, no 10, so this is a DNE. So in conclusion, for this particular function composition, f of g, we can just say that it does not exist. We cannot compose the functions in this manner. Alright, now let's go ahead and try out and see what happens when we do g composed of f. Okay, so I'm going to backtrack a little bit. G, we'll start it out with g, and then we're going to evaluate it at f at a particular point. Let's start out with 5. So I'll plug 5 in here, and then that's going to be equal to g evaluated at, what happens when I plug in f of 5? F of 5 outputs -2. And then g of negative 2, do I have any negative 2's in my x position? Well, actually I do, right here. Negative 2, and negative 2 kicks out a 6, so this would just become 6. So g of f of 5 is actually equal to 6. And you can play the same game for the rest of the points. I'll do one more and then leave the rest to you guys. So f at, let's check out what happens at 9. 9. F of 9, when I plug in a 9, it kicks out an 8. So I'm really looking at g of 8. And when I plug in 8, do I have any 8s? Oh, yeah, I actually do have an 8 in my x values for g, and that kicks out a 10. So my output would be 10. So when I compose f at 9, or sorry, g of f at 9, it results in 10. See if you can figure out the rest, the other two. I'll leave that up to you. Good luck on the rest of the assignment. See you in class.